And this is the second problem of 5 for grade 11 physics here at James M. Hill, forces in one dimension. So remember, you're responsible for being able to solve these 5 types of questions and all the subsequent parts, A, B, and C of them. So the question reads, a sled has a weight of 75 newtons and is being pulled with a net force of 15 newtons. You're given the coefficient of friction is 0.19 between the sled and the snow. So I'm going to look at it again, pick out some of the forces I have. I have weight. The weight is the force of gravity. Okay. It is not mass. Okay. Be careful with that. It is not the acceleration of gravity. It is the force of gravity. It's kind of equivalent to what you weigh in pounds. It's a force of gravity pulling on you. Net force, there we go. That's easy. It says right there, that's our net force. And we have the coefficient of friction, 0.19. So that is our mu symbol. A reads, what is the mass of the sled? Okay, so we're given weight. Weight equals mass times the acceleration due to gravity. Acceleration due to gravity is always 9.81 meters per second squared for us. So as long as our force is given in newtons, we'll get our mass out in kilograms. So put the numbers in. 75 equals m times 9.81. Divide both sides by 9.81. And we have our answer. M comes out to be 7.6 kilograms. B, what is the force of friction? Okay. So there's 2 places to look for force of friction. You can look in the net force relationship, or you can look into the force of friction and how it's related to normal force. I think that's the way to go for this one, because we're given the coefficient, we're given the normal force. Remember, normal force is our force of gravity. Okay, so force of gravity and our normal force are going to be the same thing for the purpose of this course. So force of friction equals mu times the normal force. So we have the mu value, the coefficient value, 0.19, so approximately 1/5. And the normal force is the same as the weight. Don't put the mass in here. It's the 75 newtons. Force of friction then comes out to be 14.25 newtons. Just make that a little clearer, that's a 5. And last, we're asked to calculate what the applied force is. Nice thing about the applied force, it usually only comes in one formula, and that's the relationship for net force. So reminder, net force is the sum of all those forces acting in the same direction. So for us, net force equals all the forces that are there acting horizontally. So force applied plus force of friction. I am not going to write force of gravity or normal force because they do not act in the horizontal direction. So they're independent of each other. Net force we're given in the problem to be 15. Force applied we're trying to figure out. Force of friction is 14.25, but that is opposite the direction of motion when we go to add our forces together, so I have to put that in as negative. So when you calculate force of friction, sometimes you get out the magnitude. When I put it in my net force equation, it's a vector sum, so that negative needs to be in there. So when all is said and done, adding 14.25 to both sides, 29.25 newtons is our applied force.